in this video, we are going to solve some of the problems related to density and relative density. So we have the first problem, that is a tank has a volume of 400 meter cube. Find how many tons of salt water. Density is 1.025 tons per meter cube it can hold. So whatever we know, we will write that first. So we know the volume of tank, that is 400 meter cube. And then we know the density is 1.025 tons per meter cube. And what we have to find out? We have to find out how many tons. So we need to find out the mass. So we know that the formula is density is equals to mass upon volume. So mass we need to find out. That will be so we need to find out the mass, which will be equals to volume into density. So that will be 400 into 1.025. It will give you 410. So this is mass. So this is your answer. This is the answer. And we can write the statement at last that tank can hold 410 tons of seawater. Then we will move forward to the next question. Yes, a tank can hold 320 tons of seawater. Find how many tons of oil of relative density 0.8 it can hold. We know that a relative density is equals to density of oil divided by density of fresh water. That means relative density is given, so it is given 0.8. So 0.8 is the density of oil. So relative density does not have any unit. Okay. And whatever is given, we will write that first. So it is given that a tank can hold 320 tons of seawater. It can hold 320 tons of seawater. So mass of seawater is given 320 tons. Next is given density of seawater. We know that how much? That is 1.025 tons per meter cube. And volume of tank we can find out. Density is equals to mass upon volume. So volume is equals to mass upon density. So we can find out the volume of the tank, that is 320 divided by 1.025. It will give you 312.2 meter cube. So we need to find out mass of oil. So mass of oil will be equals to volume of tank into density of oil. As we know, the question is given, how many tons of oil of RD 0.8 it can hold. It can hold, so volume we found out already, and density we know. So volume is 312.2 meter cube into density we know 0.8 tons per meter cube. So it will give you 249.8 tons of oil. So therefore tank can hold 249.8 tons of oil. We'll move forward to the next question. So next question is this. This is the third question. It is saying a cylindrical tank is 10 meters high and has a radius of 3 meters. If it is filled to an allowance of 2 meters with oil of RD 0.7, find the mass of oil. So for these type of questions, we need to first draw the diagram. So we will draw one cylinder. And it is saying the height of the cylinder is 10 meters. Height of cylinder is 10 meters. Then it is saying has a radius of 3 meters. So we'll mark the radius. Radius is 3 meters. It is filled to an allowance of 2 meters. How much it is filled? It is filled to an allowance of 2 meters. So allowance is how much the tank is empty, measuring from the top. So you should know how much the tank is empty. So this is the allowance and this is the sounding. How much it is filled, it's the sounding. How much it is empty, that's the allowance. So allege is 2 meters. So automatically the sounding will be 8 meters. And this foil has a RD. It is having this foil has RD 0.7. So we need to first draw the diagram, then we will proceed to the question. Now, what all we know? That we know the height of tank, that is 10 meters. We know the allege, that will be 2 meters. Then we know the sounding, that will be 10 minus 2, that will be equals to 8 meters. And we know the radius. The radius is 3 meters. So we apply the formula. So we as we know, density is equals to mass upon volume, and we need to find out the mass. M is equals to V into rho. That will be, so volume of cylinder, as we know, that is pi r square h into the density. So volume of cylinder is pi r square h. So here the h will be 8 meters, because the sounding of the coil is 8 meters. So pi we know 22/7, r we know 3 into h we know 8 into density is given, that is 0.7. So by solving this, we will get 158.4 tons. So that will be the mass. This will be your answer. I will move forward to the next question. A rectangular tank measuring 20 meter into 10 meters into 10 meters. So 20 is the length, 10 is the width, and 10 is the height. So we need to first draw the diagram. We'll draw the diagram. This is a tank. Then we will label it. This is the length, this is the width, and this is the height. So length of the tank is 20 meters, width is 10 meters, and height is 10 meters. Has an allege pipe extending to 0.5 meters above the tank. So this is the top surface of the tank, and the allege pipe is extending. So we'll draw the allege pipe. We'll draw the allege pipe that is extending 0.5 meters. This is 0.5 meters above the tank top. This is known as the tank top. So above it, the allege pipe is extending 0.5 meters. If the tank is 98% full of fresh water, so fresh water density we know it is 1.000 tons per meter cube. It is 98% full. This tank is 98% full with fresh water. Find the mass of fresh water and state the allege. So we need to find out the mass of fresh water, and we need to find out the allege. So to find out, we should know the volume of the tank. Okay. So we should first know the volume of fresh water is. How much is the volume? So it is 98% full. So 98 divided by 100 into, as we know, the volume of a tank will be length into breadth into height. So length is 20 into 10 into 10. Now we need to find out mass of fresh water. That will be equals to volume of fresh water into density of fresh water. So volume, as we have written, that is 98 divided by 100 into 20 into 10 into 10 into 1.000. So it will be 1960 tons. So mass of fresh water we have found out. Mass we already know now. This is the mass of fresh water. Now we need to find out the depth of fresh water. Depth will be equals to 98%, so 98 by 100 into the depth of the tank. Because we need to find out the sounding. So we will find out the sounding, then we will subtract it from the total height. So we will be able to find out the allege. So it will be 98 divided by 100 into 10. So this 10 is the height of tank. So it will be equals to 9.8 meters. Now if we need to find out the allege, so it will be equals to, allege will be equals to 10 minus 9.8, and we will add our 0.5, that is the height of the allege pipe, in this expression. So this we can find out from the rectangular tank, and this is the height of allege pipe. So it will be 0.2 plus 0.5 So in all, the allege will be 0.7 meters. That's the answer. So we found out the mass and allege. For these type of questions, the diagram is very important. So you just first draw the diagram and then you will come to know. So finally, we know that the water is filled. Till which level? The water is filled till this level, leaving 0.2 meters from top. So this is filled with water. That is fresh water. We'll move forward to next question now. The next question is a rectangular tank 20 meters into 20 meters into 12 meters. Find how many tons of oil of RD 0.8 it can hold if 2% of the volume of the tank, 2% of the volume of the tank, okay, this is very important word, that's why it is underlined, is to be left for expansion. State also the allege on loading. So same like previous question, we will first draw the diagram. That is, this is our rectangular tank. This is the rectangular tank. Okay. So it does not have an allege pipe or something. It is not saying any allege pipe is there. Only 2% of the tank is to be left for expansion. 2% of the volume of the tank to be left for the expansion. Do the marking. We'll first draw the length, the breadth, the height. We'll mark this is 20, 20, and 12 meters height. Okay, so find how many tons of oil of RD. So RD is given, relative density of oil is given 0.8. It can hold, and 2% to be left for 2% of volume of tank to be left for expansion. Because the temperature of the oil will increase, it tends to expand. So we need to leave 2% for expansion. And we need to find out the allege on total. So if we leave 2%, the oil will fill till here. So we need to find out the sounding of the oil we need to fill. Okay. So first we need to find out the volume of the tank. So volume of tank is how much? 20 into 20 into 12. It will be 4800 meter cube. Now 2% left for expansion. How much volume is to be left for expansion? That we can calculate. 2% to be left for. So 2% of 4800 will be equal 96 meter cube to be left. To be left. So it means 98% of volume to be filled. So 98% will be, if you will subtract 96 from 4800, you will get the volume, how much you need to fill the oil. So it will be equals to 4704 meter cube. So this you need to fill. So we know the formula that density is equals to mass upon volume. So mass of oil is equals to volume of oil into density. So volume we know 4704 meter cube into density is given, that is 0.8. It will be 3763.2 tons. So this is the mass of the oil which we can fill for filling it to 98%. So we need to now find out the sounding. Then we will calculate the allege. So as we know, volume is equals to L into B into H, or you can say here it is sounding. So volume we know 4704, length we know 20, breadth we know 20, and this we can take H. So H is equals to 4704 divided by 20 into 20. H will come 11.76 meters. So this what we have calculated is the sounding. So to find out allege, we need to subtract the sounding from the total height. That will be 12 is the total height minus 11.76, which will give you 0.24 meters. So this is the allege. So the allege is this we have calculated, that is 0.24 meters. Okay, so we'll move forward to next question now. Now this is the next question. This number 6. So in the previous example, if it was required to leave 2% of volume of oil loaded for expansion, find the mass of the oil and ullage on loading. So this problem is very important, where it is asking to leave 2% of volume of oil loaded for expansion. So similar to previous one, we will draw first the diagram. Diagram is very important. You need to first draw the diagram every time whenever you are facing these type of problems. Length, breadth, height. So in previous problem, we know length was 20, breadth was 20, and height was 12 meters. Now we have to leave 2% of the volume of oil for expansion. 2%, leave 2% of the volume of oil loaded for expansion. So in this type of problem, we need to first find volume of tank. The volume of tank we have found out in previous problem, that will be 4800 meter cube. It will be 20 into 20 into 12. Okay. Then we need to find out the volume of oil and free space. So volume of tank consists of volume of oil plus the free space. So volume of tank we know 4800, volume of oil we will take as V, and 2% of V is left for expansion. So 2% of V we are taking as the volume of oil. So it will be V plus 0.2 V, which will be equals to 1.2 V, that is equals to 4800. So we will come to know the volume of oil. So volume of oil needs to be loaded. It will be V is equals to 4800 divided by 1.2. So it will come out to be 4705.88 meter cubes. So this is the volume of oil. Now we know how much volume of oil needs to be loaded. So we can calculate the mass of oil, which in tons, which needs to be loaded in the tank. We know the volume, we know the density. So volume of oil into density. So we know volume of oil needs to be filled is the 4705.88 multiplied by 0.8. So it will come out to be 3764.7 tons. So this will be the mass of oil. Okay. Now we need to find out the ullage. So we know the volume of oil is equals to L into B into, we are taking sounding as X. So volume of oil is 4705.88 is equals to length we know 20, breadth we know 20, and X we need to find out the depth till which the oil is filled. So it will be 4705.88 divided by 20 into 20. So X will come 11.765. So this is the sounding. But we need to find out the ullage. Whenever we are dealing with the oil, we are always considering the ullage, not the sounding. So ullage will be equals to the height minus sounding. So height of the tank is 12, sounding is 11.765. So ullage will come 0.235 meters. In this type of question, you need to remember what it is asking to leave for expansion. That is, the 2% of the volume of the tank needs to be left for expansion, or 2% of the volume of oil needs to be left for expansion. So that's your answer, and in the diagram also we will mark. So it's a good practice to draw the diagram first. So we will mark it here also. Till here we will fill the tank. So this we found out. This ullage will be 0.235 meter. Okay, so we have solved these problems. Now we will move forward to next problem. A tank of 2400 meter cube volume, 12 meter depth, has vertical sides and horizontal bottom. Find how many tons of oil of RD 0.7 it can hold, allowing 2% of the volume of the tank for expansion. State the ullage on loading. So again we have a similar problem that is related to the rectangular tank, and in this case we have been given the volume and we have been given the depth of the tank. We will first draw the diagram as we are approaching the same problem. We'll draw first the diagram. So this is a tank. In this tank the volume is given. Volume is 2400 meter cube and depth is given. This depth is given, that is 12 meters. And what else is given? It has a horizontal bottom. So it has a horizontal bottom, that's correct. Find how many tons of oil of RD. So RD is given, that is 0.7. and it has given that 2% to be left for expansion. That is 2% of the volume of the tank. This we need to read correctly. Okay, so to solve this question, we will first write whatever is given. So volume of tank is 2400 meter cubes. Volume left for expansion is 2%. Volume left for expansion will be is 2%. So 2 divided by 100 into 2400, so which will be equals to 48 meter cube to be left for expansion. So how much oil we need to load? The volume of oil. Volume of oil will be equals to 2400 minus 48. So it will give 2352 meter cube. So if we know the volume, we will know the mass. So density is equals to mass upon volume. So mass of oil will be equals to volume into density. We know the relative density of oil. So volume will be 2352 meter cubes and density is 0.7. So it will come out to be 1646.4 tons. So mass of oil. Now we need to find out the ullage. So we know volume of oil will be L into B into H. So for this we need to find out L into B. So as we know, volume of tank is equals to L into B into 12. 2400 is equals to L into B into 12. So L into B will be equals to 2400 divided by 12. So the value of L into B is equals to 200 meter square. This we are going to use. So we know volume of oil is equals to L into B into, we can say X. X is the sounding. So this we know 2352 is equals to L into B, we know 200 into X. So X will be equals to 11.76 meters. So we know the sounding is 11.76 meters. So we can calculate the ullage. 12 minus 11.76, that will be equals to 0.24 meters. And this is the answer. So this is another question related to density and relative density. In this question, a tank is 10 meter deep, has vertical sides. Its bottom consists of a triangle measuring 12 meter, 12 meter and 10 meter. Find the mass of oil of RD 0.8 to be loaded, allowing 3% of the volume of oil loaded for expansion. So in this question also 3% of the volume of oil loaded for expansion. State the ullage and on completion of loading. So in this question, understanding is very important. We need to understand how the tank is constructed. For that, we'll draw one tank for. So that's the base. So we'll draw something like this, and like this. Okay. So there are three faces. These sides are vertical. So one is this side, another is, I will mark with different colors so you'll come to know this side, and one side is the front one which we are looking at, this side. Okay, so I'll mark it with another color, so this side. Okay, there are three sides, this one and this one, front one. Okay. And we have been given that this is 12, this is 12 and this is 10, and the height is also 10 meters. The diagram is very important and we need to understand how to draw the diagram. So once you will understand the diagram, then the question will become simpler. Now we need to calculate the total volume. So total volume means area of triangle multiply height. So area of triangle we need to find out first, and height we know it's 10 meters. Area of triangle. Area of triangle, how we'll find out? We have to first use Heron's formula. You might have studied this formula in 10th standard. So this formula, for this Heron's formula, we need to first find out S. That will be equals to A plus B plus C divided by 2. A, B, C are the sides. So 12 plus 12 plus 10 divided by 2. So this will be 34 divided by 2. That will be 17 meters. Then we need to apply area formula. Area is equals to under root of S minus A, S minus B, and S minus C. Substitute the values, that is S is 17, 17 minus 12, 17 minus 12 and 17 minus 10. So it will be 17 into 5 into 5 into 7. So this will come out to be 54.54 meter square. So we know the area, now we will calculate the volume. So total volume will be equals to 54.54 multiplied by height, that is 10 meters. So it will be 545.4 meter cube is the total volume. Now we know total volume is equals to volume of oil plus free space. How much is the free space? Free space will be 3%. So volume of oil, let volume of oil will be V. So V is the volume of oil. So free space will be 3% of V. That will be V plus 0.03 V. And it will be 1.03 V. And total volume, we know it is 545.5 meter cubes. I think 545.4 meter cubes. 545.4 meter cubes. So we will find out 545.4 divided by 1.03, which will give you 529.51 meter cube. So this is the volume of oil. So we know volume of oil is 529.51 meter cubes. So mass of oil will be equals to volume into density. Volume is 529.51 and density is 0.8. Mass of oil will be 423.61 tons. Mass of oil. Now we need to find out the ullage. So to find out the ullage, as we know, volume is equals to area into height. So we know the area, volume we know, volume of oil will be 529.51 and area is 54.54 into height. So it will give us sounding. So this is sounding. So I'll take height only. It will be 529.51 divided by 54.54. This will come 9.71 meters. So we need to find out the ullage. Ullage will be equals to 10 minus 9.71. So it will be equals to 0.29 meters. Ullage. This is the answer. A rectangular tank has a total depth of 10.5 meters and volume 8200 meter cube, which includes a trunkway of depth 0.5 meters and volume 200 meter cube. Find the mass of oil of RD 0.8 loaded and the ullage if 2% of the volume of the tank is left for expansion. It is similar to the one we have solved earlier. We'll first draw the diagram. It is again a rectangular tank, so we'll draw same diagram. But it has, which includes a trunkway of depth 0.5 meters. So we will draw one more trunkway of 0.5 meters. This is length, this is breadth, and this is height. So length is, we know the total volume. Total volume is 8200 meter cube. So this includes trunkway and the cube, which includes a trunkway of 0.5 meters. So this height is 0.5 meters. So this will be 10 meters. This height is 10 meters. This is 0.5 meters. This volume is 8000 meter cubes and this is 200 meter cubes. So it is overall 8200 meter cube volume. For all this, we need to know volume of a rectangular tank is 8000 meter cubes. Volume of trunkway, that is 200 meter cube. Height of tank 10 meters and height of trunkway is 0.5 meters. Volume of space left, that will be equals to 2 into 8200 divided by 100. So that is simply 2% of 8200, 170 meter cubes. So 8200 minus 170 will be equals to 8030 meter cubes. So mass of oil will be equals to 8030 multiplied by 0.8, that is the density. As we know, density is equals to mass upon volume. So this mass of oil will be equals to 6425.8 tons. This is mass. Now we need to find out the ullage. Calculated the mass of the oil that is filled inside the tank. So now, as we know, we have the tank and we have the trunk on the top. So the height of the trunk is 0.5 and volume of trunk is 200 meter cube. So volume is equals to L into P into H. So as we know, we have 8030 meter cubes of volume. So definitely it is the oil has entered the trunk. So volume is volume of trunk. The volume of trunk is 200 meter cubes. That is L into P into 0.5. So L into P, we know 200 divided by 0.5, that will be 400 meters square. Now we need to find out the this depth, how much it is. So we will find out by, we know that volume is L into B into X. So here the volume is 30 meter cubes. L into B into X. So L into B, we know that this is 400, this is 30 into X. X will be equals to 0.08 meters. Therefore this X is sounding. Therefore allage will be equals to 0.5 minus 0.08. This will be equals to 0.42 meters is the allage. So this is the answer. Okay. Now we'll move forward to next question. A rectangular tank has a total depth of 21 meters and volume 10,250 meter cube, which includes a trunckway at depth 1 meter and volume 250 meter cubes. Oil of RD 0.9 is to be loaded so as to leave 3% of the volume of oil loaded for expansion. Find the mass of oil to be loaded and the final allage. We will draw the diagram. Okay. So this is the tank, rectangular tank, and we have trunk at the top. We have this trunk, and we'll label it. And we know the volume of the tank is 10,000 meter cubes and trunk is 250 meter cubes. Height of trunk is 1 meter and height of tank is 20 meters and length and breadth we don't know, so we will mark L and B. Okay, so now we know that total volume is 10,250 meter cubes. So this much of oil can accumulate in the tank and trunk. But we have to leave 3% for expansion, 3% of the volume of oil loaded. So let volume of oil loaded is equals to V. The total volume will be equals to volume of oil plus free space. And we know total volume is 10,250 meter cubes and volume of oil we have considered it as V, and free space is 3% of V. So it will be 10 to 50 is equals to V plus 0.03 V. This is 3%. So 10 to 50 will be equals to 1.03 V and V will be equals to 10,250 divided by 1.03. So this will be the volume of oil. It will come out to be 9951.46 meter cubes. So this is the volume of oil. So if we know the volume of oil, then we can determine the mass of oil. So mass of oil, this we know that volume of oil into density. So relative density we know. The volume of oil is 9951.46 and relative density is 0.9. Mass of oil will be equals to 8956.31 tons. So this is the mass of oil. Next, we have to identify the allage. So how you are going to find out the allage? We know the volume of oil. Volume of oil is 9951.46. So if it is 9951.46, so we have this rectangular tank and we have this trunk. So as we know, this is 9951.46 is less than 10,000 and the volume of this tank is 10,000, so it will be somewhere here. Okay. So this will be the level at till which the oil will be filled. How much it is, so we will calculate. So for this, first we need to find out L into B is how much. So this we know that because we don't know the L, we don't know B. So how can we find out? It will be total volume, that is volume of rectangular portion, that is equals to L into B into 20. So that was 10,000 is equals to L into B into 20. So L into B will be equals to 10,000 divided by 20, which will give you 500 meters square. Now we know the volume of oil, and we know L into B, and we need to find out X, that will be the sounding of the oil. So this volume we know, this volume was 9951.46. This volume was 9951.46. This L into B is 500, and we need to find out X. So X will be equals to 9951.46 divided by 500, which will give you 19.90 meters. So now we know that this is rectangular tank, this is trunk, and oil is still here. So this is 19.90. How much is remaining? 0.1 is remaining, and this one is 1 meter. So ullage will be equals to 20 minus 19.90 and plus 1. So it will be 0.1 plus 1, that will be equals to 1.10 meters is the ullage. This is the answer.